Thank you for the forgettable introduction. Sorry, for the forgettable talk. What did you say about my talk? So, this is really not a talk for RacketCon. I'll tell you up front. It's a talk that will pale against the wonderful things you hear about poetry, music, macro expander later on. It's a talk that has been in my head for 20 years. It's been evolving. And in a sense, it was born on that date. Actually, that's the wrong word. It was conceived on that day. Anybody besides Matthew, anybody guessing what's going on that day? That's the actual conception day of Racket. And I've been thinking about this language. I've been dreaming about it. I've been philosophizing about it. I've been hoping for it. And I sketched it out when Matthew came to CMU to find out whether I was good enough to advise him. I wasn't, but he came anyway. And I had to wait for him to figure out how to implement that language. It didn't come about in a very natural way, but it came about in a good way. And here we are 20 years later. It's the 20th anniversary of our little enterprise. This is Matthew in younger days. He looks only a little bit older now, in contrast to me. Anyway, so what's Racket? What is this talk about? The talk is about what is Racket. If you go to somebody like Phil, who's sitting in the audience today, I didn't know he's going to be here, he's going to give you this propaganda spiel that Haskell is pure and functional, lazy and innocent, which is of course bullshit. We all know that. It uses monads and schmonads, and stuff like that. But they have this wonderful one-liner that they can spout out as propaganda and everybody believes it. Kind of like, certain other places.
This is good. We haven't had innocent in the sentence. We could add that.
If you weren't here, I would say it's innocent. That's right. Python. It's the one and only way. If you program in Python, there's only one way. Well, after programming in Python for 3 or 4 months now, all I can say is the wrong way, but, there's only one way to do it wrong, So, how about Racket? What in that one-liner, what is Racket? And many of you, or not many, some of you who are in academia know me for making extremist statements. And I will now admit it, frankly, after such a long career, that I do that simply to get up your selves and tease them out. I'm really an extremist in the center. I'm a radical centrist. And so my statements were very nuanced. But we found out a slogan eventually. Racket is a programming language. And you all heard the hyphen, right? That's the important part of that statement. And so what I'm trying to bring across in this 40-minute talk is what we mean, what we have thought about in those 20 years with that statement. So clearly that means the next 700 languages, like we heard in Strange Loop. I was very happy to see that this wonderful paper is remembered, the next 700 programming language. And it just keeps going, We have, if you go in Strange Loop, we're pretty much there now. Anybody know what that is? Our Babel. That's what you get when you build a big artifact. You get all these languages and nobody can talk to anybody anymore. So why would we want more languages? Isn't that crazy, right? So I'm going to give you an example that's very academic in some sense or strange loopish. But you really have this idea that this is what Alex sees when he organizes strange loop. Proposals. He has a database of people. The people have roles. Like some people are selectors of presentations. Some people are authors. Then there's security policies, because you don't want everybody to see everybody else's personal information, sign-ups, your credit card, whatever. You have a list of talks that you want to give. You have a paper reviewer map because you have reviewers throw papers out of presentations, and policies. That's a programming problem. A lot of that is done by software. Let me show you the kind of constructs we have to solve that problem. For loops. We also have while loops. We have methods, classes, modules, and packages. We talk one language when we talk about problems, and we talk a strange kind of thing when we talk about the means that we have to solve those problems. 50 years after we learned to program, we are still in this embarrassing situation that there's this huge gap. It's an unbelievably big gap between the things that we want to solve and the tools we have to solve them. Let me give you a different example that will bring us closer to the Racket image that I drew on the blackboard in this humongous room that I had as an office at CMU for Matthias when he picked me out. That's a boardroom meeting. Anybody know what a boardroom is? I know there are youngsters here, people who just learned in the last 2 years, but you have a boardroom, right? And the people speak there are all kinds of people there. There are CEOs and CFOs and CTOs and COOs, all these C people, whatever that exactly means, right? But they sit around a table and talk stuff. As a council, right? What do they talk? They actually talk different languages. If you ever listen to one of those things, they talk different languages. The council talks legalese. He protects himself primarily, and secondarily the company, right? There's a CEO who is really out there raising money and talking to customers. It's a completely different view of the guy who runs the CIOs, who talks about information, security of information. They talk different languages. And they actually talk these different languages as they sit around this table. What saves them is that they all speak English. So there really are these languages sitting on top. And in some sense, I should nest this picture. I should have another diagram like this, for example, for the chief of operations. Because up there, when he goes to the assembly floor, he speaks another operation language versus a place where he has remote manufacturing going on chips. A different language again. And these guys speak a different language again. So there's an entire tower that unrolls of these languages on top of languages on top of languages. Okay. In some sense, the talk is done right here because all I have to do is one more mouse click. That's the vision of Racket. That you have Racket at the bottom as this common substrate through which people that talk CFO or talk counsel or talk CTO or CIO or COO can talk to each other. The common thing is Racket. But we are able to tease out these languages and put them on top for each of the subproblems that we want to formulate as problems and then come up with solutions in that world. So let's refine this picture further. So let me bore you for another 20 minutes, okay? What you see here is actually different ways of plugging these languages into Racket. The first one is what is nowadays known as a fluent interface or an embedded DSL. You see this, for example, when you use Radix. Radix is particularly brittle in that sense that for every construct, you have to think about whether you are at that level or at that level. It's a very vague interface. But there's a clear distinction between those two languages. And then there are other languages like this that have very hard interfaces. I'm thinking of J's data log, for example. It's a very, very thin pipe. It's very protected. It's very protective of what goes through this pipe from data log programs into Racket programs. Okay. But then there's also this whole thing. This whole thing down here that we should talk about. How do you connect those little clouds? Maybe this thing over here. So how do you build this? The first thing is how do you build them? And then how do you connect them? Everybody knows that, right? Pop quiz. Since I'm up here, and you know me from obscure announcements on the emailing list, what's the next slide? Me screaming at you for giving the wrong answer. Okay. It's very important. If you take nothing away from this talk here today, then you take that slide along. It's not about markers. Okay. What is it about? Think about what we really write down. I'm imagining, Robbie, but you're getting close, right? We write down these languages, and there are like 40 or 50 of those things in the code base alone, and I'm sure some of you who are out there in the audience today have written your languages like that. My hashlang favorite language up there, right? These languages aren't macros. They haven't been for a long time, and they aren't just macros. There's a lot more to be done. There's a whole bunch of stuff that Matthew put together, and other people put together to make this work. Okay. Yes, we start from things like a feature is a macro. Like here's a little abbreviation. I want to have omega, little omegas, the unfold, the bound variable, blah, blah, blah. Who cares? That's a macro. But that's a small piece of this whole toolkit that we have. We have to go on and we have to say things like, let's reinterpret application. Because we don't want Racket to run in strict mode. We want to run in lazy mode. We want to make feel happy someday, right? Okay, so we make it lazy. Or we have the ability to lift the level of discourse to the DSL that you write. We don't want to report that # lambda had a bad syntax. We need to lift it up to the level of let is bad syntax, even though let is just another extension. That's not just macro. That's raising the level of discourse for all aspects of this feature. Oops. We have classification. We have ways of making it cleaner. Where's Ryan? There we go. We have ways of reusing entire languages, except for, right? We have to have this. Otherwise, you can't build DSLs quickly. DSLs are humongous abstractions. And we want you to build the one in a day. I distinctly remember Ryan coming to me and saying, I'm going to build... Why are you doing that?
Yeah, to be in front of the camera.
Oh. He came to me one day and said, I'm going to build a programming language to run one program. How many of you in this room who are not real Racketeers would ever say that in your language? You can't. We can. It's a robust language that teases out the linguistic aspect of that problem from the specific aspect. And if we ever have to ask Ryan to write a second program in that language, he can do so. But he didn't have to think about the effort it takes to lift the level of discourse to the right place and to inherit enough from other languages to just do the right thing. It took years from a conversation on a front porch in Indiana to get that. That's my favorite feature. Okay. We love and embrace side effects. Sorry, Phil. When they're useful, right? But they should go away when they're in a language, but they shouldn't affect the runtime of that language. Phase separation. It was so critical. Bruce Duba and I would dream about using Prolog as the language for running macros. Because then we would be sure that the phase side effects there would not accidentally leak into the runtime and do bad things. But I had to wait 20 years from there before Matthew actually made that dream come true. And then, by the way, there's Hygiene, and we invented it at some point. And this is the diagram that I love that Ryan drew for me to explain it in one slide. And everybody in this room knows it. Does anybody here not know what Hygiene means in that one rule? Okay. I saw some heads move back. I'm going to spend 30 seconds on that. When you have a macro, like let, and you expand it, you have two ways, two directional substitution. You have substitution into the lambda, okay, and in the context of lambda. What that means is that the contextual bindings for cons should be preserved, and the lambda bindings from the place where the macro was defined should be preserved too. So this two-way substitution needs to preserve two kinds of bindings. That is the essence of Hygiene. And we will hear an entire talk about this later on today in all kinds of weird ways, doing it much better than I can say here. But the 30-second slide is this. So that is the first part. And then, of course, you want things like chase data log. That's a Racket language. Hashlang data log. Write this in your favorite thing and embed it. And have it communicate with Racket the right way. Or your favorite substrate of language. So we need parser tools. On top of all the other tools we have, we go from there, go to the intermediate form, throw the rest of the soup at this intermediate stage, and get a wonderful embedding of these languages. That's how you build programming languages inside of Racket. So now you have programming languages, and you can write each of your components that addresses a particular part of a problem in your favorite language. The language that matches that problem. But now you have the problem of gluing together these components that are all written and talking different languages. So, back to this picture. Now you have this component that speaks COO, CIO, CTO. And they ship values down into this common language, English, Racket. Right? And what they do is they have invariants. They think of certain terms having fixed meanings. And when I ship that term, that phrase, to some other part through this common channel, like over here to the CFO, I don't want that term to experience a change of meaning. So there's this communication going on between these little clouds, and each of those guys does not want to have a violation of that meaning. How do you accomplish that? How do you protect the values that these DSLs generate, and they are Racket values that can flow wherever they want, wherever I let them flow? How can I make sure that these things arrive with full integrity, with full protection around them? Okay. I could have a picture like I had before. Many of you know that Robbie and I did something called contracts. It's not just contracts. So let me throw up a slide that does. First of all, you hope for good luck. Then you say, think positive, nothing bad will happen. Hope for the best. Don't do it at all. Just don't glue languages together. Or you hack a lot. That's really where we are. So if you want to study a good problem that has no solution, but will keep you busy for the rest of your life, go for it. Okay? So it's not quite true. We have built little building blocks, but I'm giving you these words of caution because we have not solved the complete problem. It's a wide open problem. That's why we work on Racket, and that's why Racket is the second best programming language in the world, far ahead of all others. So what's the best one, right? We don't have it yet. Threats, time. We need resource coordination. Because invariants may say that you don't leak that memory. Or you need inspectors and access to control. Right? You ship code, maybe ship code from one place to another. We had a speaker a few years ago who shipped code from a central computer to a telescope battery. How do you make sure the code has integrity? We have event spaces, sandboxes, access with wills and executors. I don't know what those things are sometimes. They just pop up in my mailbox. But let's go back to these contracts. So Robbie and I conceived in the late 90s of this idea of protecting values. We actually thought Eiffel had solved the problem, but that was a mistake. And you really need to be able to write things down like these contracts that say, well, if the window is invisible at the moment, if it is a window, and then I'm going to return, with this function open, I'm going to return a window that is just open and visible and at the top level. That's a contract. And there are other contracts. In academia, people study contracts that look like types because I can't do better. But we can do better, right? And it took us 10 years, over 10 years, to get those things right because we didn't know how to generalize this story from little lambda wrappers around this to getting it done. And then Stevie, is not here, Matthew and Robbie came along and created these impersonators and chaperones, proxies that can wrap themselves around and travel along and make sure you don't do anything bad. It took us 10 years to figure out the idea of interposition and get it efficient, okay? So it's not an easy problem. This whole scenery here is, yes, we are building blocks, but deep down we're still hacking around on composing these DSL components in a safe way. So are all these problems solved? You heard my warnings. Yes, you can program that way in Racket because it's the second best language that does that. But sometimes you're on your own. So there's lots of research to be done, lots of development to be done. And this area is still something that will continue to produce good insights. And papers too, but that's minor. Okay. So that was the first part. Racket is a programming language. But Racket, when you turn it on its side, also has become a full spectrum programming language. And it might be the first full spectrum programming language in that sense. What I mean by turning on its side is that, well, there is Racket, and we implement in Racket a different kind of DSLs, general purpose DSLs. These things. So general purpose stacks of languages. You see Racket in the middle. You see contract Racket up top, FFI Racket down here, type Racket up here, assembly Racket down here, and very Racket. They're red. I'll explain later what that means. It's like a little performance by a band. Let me at this point point out that, of course, I'm not the one who did any of that. I'm just a guy who inspires people. I don't do anything. So you all know Matthew who did Racket. That's a more accurate picture than the one before. So the real thing can look there. This is Jay when he actually isn't at RacketCon. Where is he? Oh yeah. When he comes here, he has no tie on. But I've not seen him without a tie other than at RacketCon. That's Sam for Type Racket. Where's Sam? Over there. If you haven't seen Sam, this is Sam. Why don't you stand up for a moment? There are people who are trying to find your face from the back. Okay, he's okay. He's okay. He's from Indiana, but otherwise okay. Robbie, you all know Robbie from a long time here. And there's Ellie, who's not here. That's the best picture I could find. And there are a lot more people, of course. But those are the people that really launch these particular levels of language in this full spectrum level and are running with it. And when I put people up in the red part here, I'll honestly say these are somewhat dreamy things, but we're getting there. Now I'll show you a couple of snippets how we're getting there with the next couple of slides. So these arrows no longer mean, or they also mean we want to communicate. But in addition, they mean we as programmers may want to move along that spectrum. Okay? We all know that the right way to program is without types first. What I mean by that is without type checking, but types in mind. Because it's fast, it's quick, it delivers. That's why Strange Loop is predominantly an untyped language that tolerates weird ideas, like Phil, with his propositions and types. But if you look at that, if you program in a robust way, you see that kind of stuff. That's called defensive programming. And what you export is just a stupid comment that says, well, I'm taking an image, I'm taking an image and a number and an image and I give you an image, but that's just a stupid comment. And then I have another one that says, this is what it actually does, but the name alone could have told me that. And then all I export is a place, the name of the function. That's how you program. You get things done. You make it robust with the yellow stuff. Nobody can hurt you anymore. Well, kind of. Except that the people who use it, who use this kind of module, typically read JFAR, and that's it. They don't read that part. So they may stumble about the yellow stuff and get tripped up. And so what you really want to do is, you want to move this yellow stuff into the public API. That's a contract. That's actually a contract. And the way you read this contract is exactly like this thing before. You get an object that's an image. Okay. You get another image called BG. And these are constraints about the sizes of the images, how they relate to each other. Okay. And if they're not satisfied, the thing is rejected. This is now a little DSL inside the Racket. It's a contract DSL, right? But it really is just Racket, and it's very transparent to all of you who start programming in that world. So it's easy to read. But we have really advertised now what the API is. We moved up in the full spectrum programming language, and we gained a little advantage here. This is a different color, and it really means we also had to say something about the result. It's an image. Okay, minor thing. Let's go back and look at this contract thing again without the yellow stuff, and we see, oh, we still have this line sitting here. This yellow line is really much more like a type. Okay? This is just a type. And it's not really clear here. And worse, we all know this is checked at runtime. When you harden software, when you start from a prototype that was quickly thrown together, you harden it with defensive programming, you harden it more with API programming. Maybe at some point, you want to make sure this is actually true by proof. This is where Phil comes from his propositions. This is a proposition. We want not just assurance that it works for every input we have, but it works for all future inputs too. That's when you move this yellow line from a comment into a type. And then you get static confirmation, that's called a proof, not a model check. A proof that says, this function has this kind of interface. We checked it for you and you can rely on us. That's what Sam accomplished. But we had to gray out the stupid contract. Because Sam was too lazy. He ran off to Indiana and became a dean or something or whatever, professor, and he's not doing stuff anymore. So I had to gray it out. Okay. But fortunately, I inspire people. I don't do anything myself, right? But I inspire people, and I inspired a guy called Brian Lachance, who just finished implementing, with Asumu's help. Asumu is the guy behind the camera, okay? This kind of thing. Pretty soon, in a Racket near you, you will be able to write down types and contracts together, because they are orthogonal ideas. And if you look in the literature, they're actually also a spectrum idea. There is more on contracts in J, and a student of Cormac have worked on yet stronger contracts, temporal contracts, which we don't have yet. But Jay will get back to work one day too and figure that out. While we're at new additions, another addition that's coming to actually has come to Racket here in this room through various efforts is units, typed units. Our way of doing functors like in ML. Not the new kind in Haskell that have also functors, but ML's kinds are much older. We have those two. We had them for a long time. We programmed that way, and now they're typed. Thank you very much, Dan. Where are you? Wave. There we go. Dan, with a little bit of help and push and kick from Vincent up here, moved these things into production Racket. They are out there now. Please destroy them. Bug reports prove that you exist. Dan wants to exist. Please send them bug reports. All right. Back to our little example. What else could you do? Well, maybe you want to change the language one more time. And I made up a name right here. I'm not sure this is the name that we'll end up with. DT. Pop quiz, what does it stand for? Well, you should know. Okay. So, we had contracts that are checked dynamically. We had types. Why don't we move those contracts into the type and go up one more level in the hierarchy of Racket and have the type checker also validate those additional assertions. Contracts are assertions at a boundary between two pieces. That's what we are working on right now, and I'm not sure how far he is, but Andrew, who is also somewhere in the room, I'm told, Wave, is working on something like that. And you saw a first talk in Prague if you were at ECOP.
He's talking later today.
And he's talking later today, so he'll show you how far he gets, and if Sam is leaning on him the way he should be leaned on, it will be in a production Racket near you very soon. So we went up from Racket to contract Racket, to type Racket, to contract type Racket, to dependently type Racket. And one day, Jay will figure out how to put a whole theorem proof behind this thing, and there are other people working on that stuff. How about the other direction? I'm not going to spend that much time on it. I just want to say, when you have code like this, you will also discover that there are bottlenecks. At the moment, what we give you is programming in C with parentheses. That's really what our FFI helps you do with, right? Okay. You can load in whatever C libraries you want, and then you program as if you were in Racket. But it says unsafe at the top of these modules for a reason. Because you've given up. You've given up this barrier that protects your values. Okay. And one day we may even go further down. Maybe we will let you, like in C, write down raw assembly or some form of that. That's full spectrum programming. That's what we want to offer in addition to programming language, somewhere around there. Lots more work to be done. Some of the talks today will talk about some of the aspects I just talked about, and sure, we will push out more stuff in future years. Last thesis. So Racket comes with 3 theses. A programming language, a full spectrum programming language, and from day one, we realized that we had to internalize things from the context of Racket, any language, into the language if we wanted to build full spectrum. Because full spectrum means it's an IDE at the same time. Full spectrum means it's an operating system. And I'll give you just a hint of why that is. We already saw one hint, namely gluing together DSL components. They are on their own, right? They need to be served like applications in an operating system. This is, what's that, by the way? This is actually Dr. Racket. This is all, not even all tools, but many of the tools opened up. I just clicked on a bunch of buttons and stuff popped up. That's actually Dr. Racket. Now I'll show you a different picture in a little while. That's Dr. Racket. It's a real full-fledged IDE, and I've been using, I was in Emacs. I ate with Emacs. I slept in Emacs. I read email in Emacs. I read news clips in Emacs. My window was yay big, and that whole window was in Emacs until 98. And since then, I've been working in this world. I eat the dog food, and so I see it sometimes. But when you build something like this inside the language, Okay. You need features that simulate an OS. Sometimes you realize you actually want inside that language features that other languages build into IDE. Because we are language people. We believe that problems should be articulated in the right language. And that means we need linguistic facilities to say these things that often live outside the language. And when you do that, building these things in this order is actually quite easy. But of course, you have to first come up with the right way of saying it. And it took us a long time sometimes to do that. And I'm just going to go through these features again. Some of them are there. One of the first things we realized was, don't link modules externally. Have a language of calculating the linking. What's the best language? Well, we know what the second best language is, so we use the second best language for linking modules, all of Racket. How about composing classes? Don't compose classes outside the language. Use the second best language to compose, as a language that computes composition. Right? Things like that. But you also go on and you have inspectors again, and another idea that's very, very important to us. We started this project ostensibly as, this is for little kids. Right? And you all know how wonderful it is to tell a middle school kid in 6th grade to open Eclipse, launch a project, kick the wizard, right? Make sure that all the little attributes are there, the resource files are there, right? Okay, you got it, right? We don't want anything like no projects. The language itself has to supply everything you need to run projects. Now, I will honestly admit that sometimes it goes a bit far, but we have internalized that message. First, I want to give you code snippets like before, but now I'm going to give you conversations. I had 2 conversations the last week that showed how much we, the insiders, have internalized it, and others. Like first, the insiders. Robbie, Matthew, and I have a conversation. I want to link primitives in error messages to the very documentation that they violate. Right? And the first thing Robbie says, I need compile time information. I was like, just do it in the IDE. So I was violating my own principle. And Robbie shoots back, I can't. He didn't say it violates principle 3.27 of the Racket Manifesto, but he said it doesn't internalize. Right? 2 nights ago, yeah.
You're missing one email on that.
Yes.
There's a 5th email from Matthew that's a commit message implemented.
Jay lied. I wish it were the case. It's actually not a non-trivial problem. But I wish he hadn't lied. 2 nights ago, I went out to dinner with Faray, who I saw walking late. You have to catch up on the first half of the lecture. Brian and somebody else, Duncan, is he here now? And we had this conversation again. And so there are common Lispers, and they're coming from common Lisp, and common Lispers think they have macros. But he admitted it afterwards, he don't. If you know anything about common Lisp or closure macros or things like this, all of them end up in eval when, divide by 3, multiply by 17, and hope for the best. You just don't know when things run, how things work. It's a pain in you know where. And then Brian says, but in Racket it just all works. Because we internalize the idea again. We require for syntax, we require for template. It just works out. You don't need extra-linguistic features to tell the compiler what to do. It's in the language. It's a fundamental principle. If you are a programming language researcher, and we are programming language researchers, trying to push out something good to the world, you think, what can be done with a language to say the right thing at the right time? Don't leave it to accidents in the IDE or the OS or some other build tool.
I didn't say what I was painfully aware of that. Let's go a bit
He is pained, he says. There's one more thing that became very clear to us. It has nothing to do with the language per se, but it is so important it has to be mentioned now. here because academics usually don't think of that at all. There are very few projects in academia that from the very first day say, we need a design feedback loop. Here is what I mean by a feedback loop. We need victims. We need people who suffer, people who are in pain, people who push back. And there is nothing, no insult, nothing bad meant here, but there's nothing better than middle school kids hacking on your software. It is the most painful experience any developer can ever have. So when we decided to create an outreach project, going out into the barriers of Usenet and pushing out Racket into the classroom of mathematics, we did not know what we were in for. And we got pushback. And because of that incredibly fast pushback, and also colleagues who would just go on our keyboard and go like that and crash everything we had, we were up and running and had polished products that were delivered with a mouse click in a very short time. Okay? That is the envelope around Racket that is very, very critical. But we also need a lot more feedback. It is true that middle school and high school kids inflict a lot of pain on developers. Even though you have 100,000 kids on your software, the pain points you get back are almost always the same. When people then take your software and push it into production projects from all kinds of obscure projects funded by agencies and DCs to your hobby projects or whatever you want, you're stretching the limits of Racket too. What we really need from you is a lot more feedback where you experience pain in materializing this vision that we have with Racket. So this is a little appeal at the end of my time here to you to be a lot more proactive in filing GitHub issues and make Sam work again on Type Racket. And not just him, me too. Takeaway. It's time to wrap up. First slide is, this is what you get from Racket as the programming language. Okay? We have a programming language, we have a full spectrum programming language, and we have internalized facilities. I need to have one caveat here. This came across the first time I pushed out the manifesto on my webpage. A lot of people push back and says, you can't internalize everything. And of course we don't. Everything here is with a grain of salt. We're trying to achieve those dreams. When we know they're wrong, we back off. That's very important to us. We know that we're wrong, we back off. And to back off, we have, for a long time, we have used an academic feedback loop. Academia is a very bad medium to get feedback on a programming language design. It's a horrible one. It's almost useless. The one that we really need is you. That's all I have to say. Thank you very much for coming. Thank you very much for listening. And I want to thank a lot of people who have contributed to this project. Any questions? So he's in charge. He will tell you what we do now.
Seems like if you read the microphone.
You can have mine.
We'll get this. There we go. I was warned that a microphone was tricky. All right, do we have any questions? We have time for questions. Yes.
Wait for the mic so we get you on the recording.
In what areas have you been wrong and had to back off so far?
Let me try to find a good example.
It's just an idea.
No. Let me give you a very, very concrete example where I was horribly wrong. My desire to have full functorized programming was born during my sabbatical at CMU, when I wrote a paper called Extensible Denotational Semantics. I tried to implement it in ML. I miserably failed. I traveled to New Jersey to get the SML implementers to give me recursively linkable functors. I didn't. They plainly refused. I said I was crazy. Nobody would ever want that. That's in 95. By the way, nowadays every ML has that, just so you know. So I came back, and when we started programming, I really felt that we needed this kind of programming because we were building an extensible programming language. BSL, ISL, ASL, all the variants on it, all the tools need to work. It clearly was a case for extensible for functorial program, full functor programming with recursive linking. So I pushed Matthew to give me that. We had it for, I want to say, 5 years. And looking back, it was a complete failure. Not a complete failure. There are situations where this kind of programming is called for. But if you do it for everything where you have modules, it is awful. And so we had to rewrite it. Give you a second example. It's much easier to explain, much easier to say and summarize. We had a new class system for every release for I equals 1, 2, 3, and 4, I believe. Correct. A new class system, we started with multiple inheritance. We ripped out multiple inheritance because it was a bad idea. We put Nixons in. We still had closures in the class. We ripped out those, had real methods. It kept on going on like this. So we had to back out of these early design decisions a lot. And we stabilized. And the stabilization came in because we had the feedback loop. We actually coded for real. We delivered the code. We realized what pain it was. That's how we back out. And there are many more examples, but these are good, two easy to explain examples. There were more questions. There. Behind you.
I'm Byron Davies. This is a question not so much for you, but for the audience. I'm a user of Racket, and I'm glad you like users. But I'm in awe of these people who actually work night and day to make Racket better. But I have a question for the audience, and that's how many people here are not in that category, but are actually users of Racket, that use Racket for real applications?
At RacketCon, okay.
Thank you.
Behind you again. Behind you.
Keep turning around, so there's no behind.
Who do you think is what is inspiring you with regard to dependent types? Who's doing it right, and what ideas do you want to steal?
I will let Sam answer this question. I have my ideas, but I don't want to say them right now.
So I think there's a lot of people who are doing neat things with dependent types. If I had to pick one person to talk about, so I would mention Edwin Brady's Idris language. So I recently saw Edwin give a talk in which he described Idris as Pac-Man complete. And I think the idea that the first program that you want to show is student-level educational video games is an idea very dear to many of our hearts, and so that's a sign that they're doing things that are, I think, importantly applicable to what we're thinking about.
I had a short question. In your last remark about Racket does not internalize everything, weren't you missing at the end the word yet?
I didn't say yet.
Exactly. Shouldn't you? Or why shouldn't you?
No, I was intentionally saying we do not, like before, for a long time I thought language solves everything. And I think that's just a mistake. I will admit that languages are good for a lot, but there are also people there are linguists, like language people, but for real languages. And they have this conjecture too, and I think they're wrong too. Language is not everything. And I think there are things in our world, in software, that we should not put into the language. They're too hard. And there's lots of things that are not in Racket, so it's obvious. We sometimes push forward, and we realize maybe it wasn't worth it. And then we let it lay, there and don't care. But there's no yet. I don't think the whole world can be internalized in the programming language. There are things outside, and we'll leave them there.
Do we have any more questions?
If you don't have any, there's a longer break.
Yep.
Hi, I'm new to Racket. So you said you're working before with Emacs, and then you decided to work on the Racket environment. Can you compare both?
Yes. I did not give up Emacs completely. I will admit that. But I gave it up for program development, for parenthesized program development. And as I tell Robbie every so often in secret, now in public, on occasion I quit Dr. Racket. I go to Emacs to program there for about 5 to 10 minutes and recover and go to Dr. Racket. Because it is much, much faster to go through that cycle. So there are tasks still to this day that are quite hard. I like e-tags, for example. I do e-tags running, and it just, they don't work that well in Dr. Racket, as an example. There are other examples where I'm faster going into Emacs and switching back. But partly I've internalized the idea of programming in Dr. Racket. I was the first user, the first full-time user, and it was really, really hard. My second one, excuse me, probably wants to be the first. And so that's what I do. So I think there are strengths to both. I have keyboard macros in a way that I don't have in Dr. Racket. I have some amount of keyboard macroing was there at some point, for me only, nobody else knows. There's another example where I go forth, but there are other things I did in Emacs, and over time I gave them up. But comment from Robbie?
When Matthias left Emacs, there was no Racket mode yet, so the story is a little bit different in the last.
I created a Racket mode, but it's broken.
Yeah, there's another one, Greg's.
Yeah. So I used a ski mode, and that's the actual answer. It was a ski mode. The ski mode was okay, but it wasn't great for Racket. And I said, why not try Dr. Racket? And I never went back. There was another question somewhere that popped up. Oh.
Last call. Any questions? Okay, I don't have eyes all around my head, but it doesn't look like there's anybody with more questions. So let's thank Matthias again.